Hi, it's Lilia, and this is my third of 3 videos showing you a pipeline for processing sociolinguistic data. So to review, we started off with an interview as a WAV file. Then in the first video, I showed you how to use some automatic tools to get a computer-generated draft TextGrid transcription of your interview. Then in the second video, I showed you how to take your computer-generated draft TextGrid and go through carefully by hand and hand correct it to create a gold TextGrid using Praat. And then in this final video, I'm going to show you how to take your WAV file and your gold text grid and put it through DARLA, which in turn makes use of the Montreal Forced Aligner to extract a CSV file of vowel measurements of the position of the tongue in the mouth when pronouncing vowels, which will then serve as input to a statistical analysis. The last step ultimately is going to be your statistical analysis, but I won't show you that here. I'll just show you how to get the CSV that you would use as input for it. So here's what we're going to do. We're going to upload a WAV file and a human-corrected gold text grid to the semi-automated version of DARLA. DARLA is then going to align each word with its time-stamped sound stream using the Montreal Forced Aligner so that we are lining up exactly every word with its audio so that we can measure the vowels while that word is being pronounced during that word's time. Then also what DARLA is going to do is it's going to map each orthographic word to a pronunciation dictionary. So for example, if we want to study the E vowel, we want to study it in the word beat, but also the word wheat. Even though they're spelled differently with different orthographic vowels, they are phonetically the same E vowel. So we're going to use a pronunciation dictionary to standardize the representation so that we can find all of the E vowels, however they're spelled, wherever they occur. Then DARLA is going to measure the F1 and F2 formants, which again represent the position of the tongue in the mouth at various points in the duration of each vowel, and it's going to put those measurements into a CSV file, which we will receive via email, and then we're going to save and store it, and that's what we're going to do. So I'll show you how to do all of that on my desktop. So first I will close out of my slideshow and show you on my desktop. So here I'm doing this with a passage because it's a little smaller and easier to process in a live video. So I'll show you what our input is going to look like. So this should look familiar from the last video. So here we have a WAV file and a text grid, and we're opening them in Praat. And this is a hand-corrected text grid, so we know it's high quality.
3495.
So all of my interviews start, and all of my passages, all of my data start with a person saying out loud their unique anonymous 4-digit number. So that's what she's saying here, 3495.
3495.
And we have these correctly transcribed chunks. So that's our input. So now we're going to go over to the DARLA website. So we'll go to the DARLA website, and this time we're going to click the semi-automated version. The semi-automated version means that we've had some human input, we had a human corrected text grid that we're uploading, but also some automatic input, and then it's the computer that does the alignment and extraction of the vowel measurements. So we'll go here and we'll click on the version that says audio with transcriptions showing sentence or breath group boundaries as text grids, because that's what we have. So we'll click try it out, and we will upload our file, our WAV file. We'll upload our text grid. And for my particular project, we will leave everything here the way it is. So we will filter out stop words, which means we're not going to measure the vowel in words like the, because it's so common, it's so phonetically reduced. We're going to filter out unstressed vowels. So for example, in a word like extraction, we're only going to study the a, the stressed vowel in a multisyllabic word. And we're going to filter out outliers. That's for my particular project. Then we'll put in my email address and we'll click submit. Depending on how big your file is and how fast your internet is, this might take more or less time. But for this live video, I actually already did it, so I can show you what's going to happen once that goes through, once it's uploaded. So here we have another screen where we are going to put in the speaker's ID. So in your project, the speakers probably all have some identifier to keep them different from each other. So in my project, they all have a 4-digit number. So we're putting in her ID as 3495. And then for voice type, I'm going to click high. And that's because the vowel measurements do better when they kind of know what pitch to expect. And a person's pitch is often related to their sex or gender. And this person is a woman, so I'm going to say that she has a high voice type. Then I will click submit. And again, we might have to wait a minute, but again, for this video, I actually already did this in advance, so I can show you eventually the email that you will get here. So I'll go over to my email and I'll show you what we receive. So we receive an email from DARLA that says, here are your formant extraction results. So that looks good. So we're going to download formants.csv and formants.fnorm.tsv. And the first thing we're going to do is we're going to correctly label them because we might have CSV files from a lot of different people and we want to make sure that we keep them all straight. So 3495, so I'm going to label that 3495 passage formants, and then I'm also going to label this 3495 passage formants, both the CSV and the TSV. So now I'll show you what's in here. So here's a CSV file that DARLA sent us. So we remember the first 4 words she said were 3495, 3495, and here they are. Each one is a row. So every time she talks, she's the same person, so her number is the same. Every time she talks, she has a high voice type, so voice type is the same. But here she's saying the E vowel, and then here she's saying the I vowel in 9 and 5, I. Don't worry about 4 because that's before R, so it's a little different. But 3 is the E vowel, 9 and 5 are the I vowel, right? And then here is what we have. Here is the, I think, mean F1, F2, and F3 for this vowel. And then when we scroll over to the right, we'll see a few other things. We'll see the duration of the vowel, which is how long it takes in seconds. Then we'll see also the, so for example, for the word, let's look at the word 9. So in 3, there's no consonant that comes after the E because the consonant is the final consonant. But for 9, it actually tells us that the manner of articulation of the following sound is nasal. So in 9, the N is a nasal, which means the air comes out your nose, right? It's also apical because it's produced on the alveolar ridge. So we might want to take into account these pieces of information in some sort of statistical analysis because we know that the consonants that surround a vowel have a large effect on its phonetic realization. So DARLA has given us that too. Then when we scroll a little more over here, we see here we have the F1 and F2 at 20%, 35%, 50%, 65%, and 80% of the vowel's duration. So the vowel takes place over time. When we say 9, maybe the position of the tongue changes over the course of the vowel. So we can look at the F1 and F2 at different time points in the vowel to study that type of trajectory information. Then over here we have the word realized in a phonetic alphabet. So this is the pronunciation dictionary. So 9 is N, I, N, 9. So it's been standardized to distill the pronunciation rather than the orthography. And then that's about it. That's the main things that we care about here. So I'll close that. Then the next thing I'll just quickly show you is what this text grid looks like. So it's sending us a text grid, but the text grid is actually a little different than the text grid that we input. So I'll show you what it looks like. I'm downloading this new text grid and I'll show you what it looks like and how it's different than the text grid that we started out with. Great, so we'll view and edit. So you'll notice this looks a lot different. There's a lot more boundaries here. So here we'll go over here, and remember in our original text grid, this whole thing, 3495, was just one chunk. But now this new text grid has gone through the aligner, and the aligner has chopped it up into little pieces so that each piece is a word.
3, 4, 9, 5.
So that's what the aligner has done, and that is how we are able to extract vowel measurements for each of these vowels separately. So this is also kind of illustrating why it's so important to add in filler words like and when you're doing your hand correction of your transcription. And that's because we don't want the aligner to get confused. If a person is saying phonetically, but orthographically that's not represented, then the aligner is going to get really confused and maybe try to align or in the speech stream with some orthographic word that is not or and that will mess up everything. So this is kind of just showing you the importance of adding those filler words back in when you do your hand correction of the text grids. So that's the aligner. I just thought I'd show you that. Then I'll show you a few other things that DARLA sends us. So DARLA sends us also the transcription just as a text file in case that's interesting to you. And it also sends us a vowel plot. So this is kind of a visualization of the information that's in the CSV file. So again, E is the highest frontist vowel. The tongue is at the top front of your mouth, which is what this graph is supposed to represent. This is E, top front of your mouth. And so it's all the way up here. And then these plots are actually most meaningful when compared to other plots. Just kind of on its own, it doesn't mean that much, but we can see, for example, that she has a face and a dress vowel that are at least somewhat far away from each other. For example, this is her A vowel. So that's kind of a visual of the CSVs. But so that's kind of what DARLA sends you. And then I'll just show you that for my particular project, the last thing you're going to do is you're going to upload your data. So you put your data through DARLA, but then you probably want to also store it, right? So for my project, we're going to make sure we put it in our Box site. I think I had actually already done that, but I'm just doing it again just to show you that that's what you should do. And you should also, of course, have made sure that the TextGrid is in there too. So the TextGrid is also in here. We want the TextGrid and the CSVs to all be in here, as well as the wave files. So that's all I had to show you today. So I will head back over here and I will say that we've now shown you how to process your sociolinguistic data using this pipeline. So that's all I had to say. Thank you very much for watching and thanks for your work on this project. And I'll see you next time. Goodbye.